Okay, so this is question number 36. It's an interesting question because my first instinct was, ooh, this is complicated. Maybe I could show them how to do this in the calculator. But then it dawned on me, trig functions in the calculator are really interesting because the only trig functions that you're going to find are going to be sine, cosine, tangent, and their reciprocals. Okay, so putting this in your calculator is going to require that you know the reciprocal functions and the quotient functions anyway. So it's easier just to do this by hand. So I want to quickly show you, and this was me figuring through it just a second ago. There are 6 trig functions that you need to know. Okay, and those 6 trig functions are, first of all, the 2 OGs, and the OGs are the trig functions that every other trig function can be built from. Okay, and those are the sine and the cosine. The sine is opposite over hypotenuse, which in this triangle's case, the sine is 3/5. The cosine is adjacent over hypotenuse, so in this picture, it's 4/5. Now, those 2 are the only 2 you need to calculate every single other trig function. All right? Even though you know that the tangent is opposite over adjacent, we actually could do all of the trig functions with just sine and cosine. So let me show you how you do that. And this is a definition, a thing you need to know. It's actually a property of the tangent, a quotient property, and that quotient says that the tangent of x, and this is true always, can always be found by taking the sine of x and dividing it by the cosine of x. So the tangent of x is equal to the sine over the cosine of x. If you actually were to calculate that, the sine of x is 3/5 over the cosine of x is 4/5. Well, 3/5 divided by 4/5 is the same as 3/5 times 5/4, which would be 15 over 20, which would be 3 over 4. And if you look, sine over the cosine, remember tan is OA, opposite over adjacent, and the opposite is 3, and the adjacent is 4, so it's 3/4. Now, why would you do that when you have all 3 lengths and you know that tangent is opposite over adjacent? And that is because you don't always know all 3 lengths, and you don't always have opposite or adjacent. So the tangent of x is useful in figuring out the tangent of x, I should say. Back up. The sine of x and the cosine of x are useful because you can break tangent of x down into the quotient of the sine of x over the cosine of x. All right, there are 3 other trig functions, and these are the reciprocals of the trig functions that we've already stated, the sine of x, cosine of x, tangent of x. First of all, it's the secant and the cosecant. It's the opposite of what you would think. The secant is the reciprocal of the cosine, okay? And the sine of x has the cosecant of x is equal to 1 over the sine of x, okay? So the reciprocal, 1 over, by the way, if you look at these, here are the reciprocals of these numbers. Like, for instance, I did this just a minute ago. For instance, if I had 3/5, the reciprocal is 5/3. 5/7, the reciprocal is 7/5. We know how to do reciprocals of fractions pretty easily. The reciprocal of 6/19 is 19 over 16. However, doing a reciprocal, that's not an operation, okay? But there is an operation that if you do that, you will always have the reciprocal. So in situations like this, adjacent over hypotenuse, the reciprocal is hypotenuse over adjacent, okay? And here, I had a 6 right there. That's where it's sort of a little weird because we're not accustomed so much to doing reciprocals of whole numbers, but the reciprocal of 6 is just 1/6 because remember 6 is 6 over 1, which means if you have some unknown number or quantity of any kind, the reciprocal can be calculated by taking 1 over that, okay? 1 divided by whatever you're looking at is the reciprocal of that, okay? So that is why if you have the cosecant of x, it is equal to 1 over the sine of x, which means essentially that would make it hypotenuse over opposite which would be 5 over 3. The secant is equal to 1 over the cosine, which means it's hypotenuse over adjacent, which in this case would be 5/4. And then the tangent of x. The tangent of x would be the reciprocal of the sine of x over the cosine of x, which means, sorry. The reciprocal of the tangent of x, first of all, is the cotangent of x. Cotangent of x, okay? And it is the cosine of, well, it's several things. Let me just rewrite that. The cotangent of x, you could write that as 1 over the tangent of x. You could also write it as the reciprocal of the quotient that you know is the tangent of x. So the cotangent of x is the same as the cosine of x over the sine of x. And that would mean it's adjacent over opposite, and that would mean it's 4 over 3. I'm going to tell you, though, these things, don't memorize those. Just know that 1 over a fraction is the reciprocal of that, and that's how you can figure those out. Okay? Now, I want to tell you, too, that you can square all of these identities. Okay? The sine of x can be written, or can be squared, and this is how they write it. The sine of x, that quantity squared, for some reason, they always write it like this. Sine squared of x. Okay, but in terms of putting this into a calculator, if you were ever to put sine squared of x into the calculator, you won't see sine squared of x. You're going to just see sine of x, and you have to know how to put this in so that it actually is squaring that quantity. In your, well, both your calculator that you're going to have on the GACE and also just the TI-84 that you use on a regular basis, when you square the sine of x, the way you have to type it in is really strange, because first of all, you're going to be squaring. Let's say that I wanted this, that x is equal to 30. Okay, the first thing you would have to do is type in the sine. Okay, and it will automatically open a parenthesis, and you need to be super careful about this. Okay, and that is when you put 30 in, close the parenthesis. If you don't close the parenthesis and you go ahead and say squared right here, up squared, that is not the square of the sine of 30. That is the square of 30 signed. Okay, in other words, that's the sine of 900, which is not what you're intending to do here. Okay, so this is how you do it. You close the parenthesis. You have to close the door on the 30, then use the caret key, and then square it. Okay. And again, all of these trigonometric functions can be squared. And in fact, if you have the tangent squared of x, it is equal to the sine squared of x over the cosine squared of x. Okay, so they're still true under exponents. And there is one squared scenario that you absolutely must know, and that is this, that the sine squared of x plus the cosine squared of x is equal to 1. You may recall that we talked about on the unit circle, and hopefully you have been practicing, just drawing that unit circle. It's called the unit circle because it is a circle. Oh, that's terrible. It's a circle whose radius is 1. Radius equals 1. We also talked about how in the unit circle, any coordinate on the unit circle, like right here, there's 1. Okay, if you want the coordinate of that point on the circle, it's going to always be the cosine of x, comma, the sine of x. So this identity is called a Pythagorean identity because this is the cosine of x, this is the sine of x, and if you did the Pythagorean theorem on that triangle, cosine squared of x plus sine squared of x equals 1. Okay, that is why. The reason sine and cosine is equal to sine squared plus cosine squared equals 1 is because of the right triangle in the unit circle and the sides squares added have to equal 1 because it is a unit circle. So looking at this, there's really not an easy, super easy way to look for or do this in your calculator, because your calculator only does the 3 sine, cosine, and tangent functions. So you just have to know, all right, cotangent is the opposite of the tangent, the reciprocal of the tangent. Okay, the tangent is sine squared of x over cosine squared of x, or I should say the tangent squared of x is the sine squared over the cosine squared, which means the cotangent squared should be the cosine squared over the sine, which means that is not true. They went from one step to another and made an error on step 1. Okay, everything else looks the same, checks out, those are the same. Okay, going down, cosecant is the same, but something's happened with sine squared of x over cosine squared of x. They kind of skipped a step here, but this is what they did. Sine squared of x over cosine squared of x plus, remember 1 is 1 over 1. They just did common denominators here. So times cosine squared of x times cosine squared of x. And then they added sine squared plus cosine squared of x over that common denominator, which was cosine squared of x. That's where this came from. Okay, so that's all correct. There's nothing wrong there. They just combined the two fractions, or the number and the fraction. The next step, let's see what changed. Okay, cosecant of x. Remember cosecant? Cosecant is 1 over the sine of x. All right, but that's not, they did it wrong. They wrote 1 over the cosine squared of x. That should be the sine squared of x. So there's another error right here in step 3. Okay, so lastly, they added the sine squared of x plus the cosine squared of x and got a 1. Okay, and so that's where that came from. So there isn't an error from step 3 to step 4. So the answer to this, where is the error? The two errors are in step 1 and step 3.